Yeah. Okay, so this is me. Okay, this is me. I'm originally from Spain. I've been living here in Ireland for more than 11 years at this point, and I really like what we do at work. So I assume everybody does because we are here on a Saturday. And that basically led me years ago to create a blog and a YouTube channel. So I am a YouTuber as well, and that eventually just led to the Microsoft MVP. But obviously, neither YouTube or the MVP is paying any bills. So I work for Muse, which is a property management system that is basically software for hotels. Okay, you go to the hotel, you have a check-in, and you basically fill up your information. You have your auto kiosk where you do everything automatically. It gives you the key, etc. All that stuff. So we are more than that. It's more an ecosystem. So because we bought recently an events application and it's integrated. So if you are interested to work in the hospitality industry, Google us because we are hiring. Okay, we are a scale-up and we are hiring, and it's very challenging but very rewarding at the same time. And that QR code there is basically my LinkedIn. That doesn't work much, but there it is. That's my LinkedIn, so you can add me if you want. So I love what we do at work, and I do love going into the conferences. So I like going to conferences. You talk to people, and you start to hear these kind of sentences whenever distributed systems or monoliths are in the conversation. And you need to basically, or you start to listen to them and you start to analyze them, and you're like, okay, so there is some gap of information here, because if you are complaining so much for certain architecture, why is the company you're working for using such architecture? So this gap between basically the strong opinion and the missing context is what I want to talk in this conference, which is basically what you gain and what you lose when you pick one or the other. Because basically, context is king. Okay, there is no other way. Things are done for a reason, on a specific moment in time, and we have to understand this. So why are we picking A instead of B? Should be documented, it should be shared, and your company should basically share this information, because otherwise you are going to end up on a place that some people is going one way, nobody else knows where these people is going, and you end up frustrated, you don't like it, you leave, and overall this is bad for the business. So sharing all this information is important, but we just keep going. Just to be clear, before starting, I want to mention that there is no amazing architecture that is going to fix everything. All of them are absolutely terrible in the wrong context, because a monolith can be well structured and be amazing, or be an absolutely pile of shit. And the same happens for a distributed system. It can be amazing, or it can happen that a little spark somewhere down the line, it just sets everything on fire. Because on normal circumstances, when you start a company, you should start small. We're going to start talking about the monolith. Basically, when you start a company, or you start to work for a company that is trying to do something, you are not really doing, or you are not really building technology. Okay? You are fixing or creating a solution to a problem, and that's it. And what we want, or your customers basically don't care if you are using clean architecture, DDD, microservice, or I don't know, your architecture that is only for your company has been blessed by Uncle Bob himself. They don't really care about this. They only care that your software fixes a problem, and it doesn't crash, it does it properly and fast and hopefully cheap. This is why normally starting with a monolith is the correct approach. Now, here we are going to see some benefits of why this is a thing. Because basically, on normal circumstances, you are going to have a small team. You are going to have your monolith working in your monolith there, and then you have your small team, which provides very speed of development, which is quite fast, because you basically have one code base, one pipeline, one or two teams, and you are just working there, and things get done, things get deployed very quickly. Everything is basically simple, because like it's a pipeline, it's a single pipeline. You may have a team that is in charge of deploying, but everybody basically knows more or less how the entire system works, and this is very important. because anything or anybody, can work on any part of the system. And of course, because everything is simple and faster, it's just basically cheaper. Okay, this less means like you are going to spend less money. You have one pipeline, one code base. This means it's just less DevOps overhead and less people to manage all this stuff. Fortunately, things are great until the moment they just aren't. And this moment is surprisingly predictable to notice when it's going to happen. So, as we mentioned, we have our team, and our team is working on the monolith, is adding features, is adding a lot of stuff, everything is great, customers are super happy, but then you are starting to add a lot of features, and you start to need more people to manage all these features. So this means that the business is growing, or the team is growing, or both at the same time. So you have your small team, things get fixed straight away, so there is a bug, it gets fixed in production before your manager has told you, okay, there is a bug, we have to fix it, somebody already have done that. But then you need more people. And here is where things start to couple. So things or code that should not talk to each other, they will start to be best friends. Here is where the problems happen. Okay, it's like I have like a system that is a shop, and the inventory or the order team should not talk to the inventory tables, but here we are just querying everything everywhere. And this is an absolute mess. Here is where that starts to happen. There is no conventions anymore, because we are now 20 people, and 20 people is 20 different styles of coding. And of course, the temporary solutions. So temporary solutions is this kind of code that you add there temporarily, but this temporarily become permanent, but nobody is maintaining, but things are just there and just stays there. So all of this overhead is just basically making everything slower. Your pipeline is going to be slower, your onboarding to the people is slower, fixing bugs is going to be slower, and this just keeps going and keep going. It keeps going because monolith is still viable, but then you have more teams, and this has become a battlefield now. Now you are going to have people modifying the same module or the same code, 2 different people, 3 at the same time, and this is going to cause conflicts. Now, what conflict means is that your code and the other person's codes are not compatible, and one of those person is going to need to modify it. And there is no other way. So one is going to be faster and merge as quick as he can, so the other one has to basically spend the next 2 days doing that. And this just pisses off everybody. This don't merge on a Friday kind of legend that we have in IT. This is the scenario when that happens. Okay? When your pipeline is starting to take 2 hours to deploy, is when you're like, okay, it's 12 o'clock on a Friday, I'm not deploying because I don't want to be here at 3, and if something fails, then I have to be all afternoon because it takes 2 hours to get fixed as fast as it can, at least 2 hours. But this doesn't finish here, because the last step is when everything is just very, very slow. It's so slow that nobody wants to touch absolutely anything that they don't own, and of course nobody knows what they own. And when you have to do a change, it involves changing so many things for so many different teams that sometimes you're like, why would I bother to do this? And you go there and do a little hack, well, not me, but you go there and people do a hack, and that just lives there forever. But years later, nobody knew that was there, and that may cause a bug. And basically, what's happening at this point is that what it was a great asset at the beginning, which was the monolith, nowadays is just basically slowing everything down. Because obviously, if the pipeline took 2 hours here, now in here is taking 4. 1 hour for each environment, basically. So this is where we are at Muse, or where we face ourselves at Muse. So as I mentioned, I work for Muse, and we have our monolith, and we started to add features, features, and features. We have a great system, it does a lot of stuff, and we have only one database. And this becomes our problem. Because, so when you have one database, you're basically querying with all your new features to the same database, to the same database, to the same database, and you're like, okay, we need a bigger database, and we need a bigger database, and we need a bigger database. But there is a thing about databases, that they have a limit. And you can basically throw money at the problem for so many time, not more than that. And we reached the point where scaling the database wasn't possible anymore. So at that point, we decided that we had to do something. So that something, among other things, is started to move to a distributed system. Okay. So first of all, you go to Google, you go to Google, without the sponsor, and you basically Google, I don't know, distributed system or microservices in there, and everything looks great. You see an image like this, where everything looks perfect. So you have one API service calling a different API service over an HTTP call on the network that works, and it is amazing, and then you are like, okay, but I don't want the user to wait. I used to have jobs. How do I do this? And then you discover that there are queues and consumers, and you are like, okay, this is perfect, this is amazing. Now, the problem we have here is that this is not even the cherry on top of a cake. This is less amount of that. Because when you are moving to a distributed system, you're going to have a very, very complex system, or you're going to have a lot of things that were granted in the monolith that just basically don't happen here. So just to give an example, you are in your monolith and you have class A calling class B, and this is fast, okay? It's class A, class B, it just goes in memory, it's automatically, it takes nanoseconds to finish. But you have decided that you are going to move that API in particular. And that API in particular now is not a memory call, now it's basically a network call. And network calls, let me tell you, they are not your friend, okay? They can cause many problems and they can break for so many things that is not even funny. And on top of that, you have, obviously, the latency. So what it used to take nanoseconds, now it will take a few milliseconds to get the information. Overall, or in reality, this may not look like a problem until you realize that that call that you were doing from module A to module B was in a loop that at the same time was inside another loop. So the process that used to take, it wasn't too performant, but it used to take maybe half a second. Now it's taking you a minute, and you don't know why. So basically, you have to rework the whole thing to make it work properly. And then you are expecting as well this call to take, 20 milliseconds, for example. But what happens when you have your call is taking now 50 milliseconds, or 1 second, or 10, or 30? What do? Do we cancel this? Do we cancel and retrain? Is it going to break something? Do we just wait forever until this finishes? So those kind of thinking is basically what you are buying into when you move to distributed systems. And normally you will have this thinking as well if you have third-party integrations, but now with your distributed systems, everything is a third-party integration. And this is basically the difference. So let's assume we know this and we like it, and we decide to move our little API out of the monolith. So you're moving there, and you're like, okay, I have my logic here, now what? So as I mentioned earlier, we used to have things for granted in the monolith, things that just work, that somebody just configured back in the day, and they were working. But now, you have to put that little API somewhere. So for that is where the cloud providers come from. Okay, you have, I don't know, Google, AWS, or lo que sea, or whatever, and that's it. And you're like, okay, this is running here, that should be it. But in reality, is that not? Because what it used to be app config or a web config or whatever config in your system now becomes a service called a configuration service. Of course, some of that configuration is going to be a password. A password cannot really be in a configuration because it's a security issue. For that, you basically need a secret storage. On top of that, because you want to call your service B from your service A, you cannot say, okay, service A, give me whatever. You need a URL, and for that, you have your service discovery. Now, there should be a reason why you're moving to microservices, and one of those is going to be scaling. To scale, you basically need a load balancer on top, and in front of that, you are going to need an API gateway if your application is being accessed for third-party companies. So you may think that this is it. The reality is not. Earlier, we mentioned that we are moving jobs basically to a new system. So now we have, I don't know, brokers or service buses or Kafka, RabbitMQ, PubSub, all of that. All of that, it just comes here into play. Different one of those are used for different purposes, but all of them can be used to send messages from A to B, basically. And of course, you have a distributed system now. What means that you have only a little portion of the whole process that your customer is doing. This means that if something breaks, it doesn't need to break on your application. It could break three applications down the line, but you get the error. And to know that and to be able to trace that, you have monitoring and observability, which, by the way, this is very important, very expensive, but everybody has to use it. And of course, there is many other services. So AWS, I think it has more than 200, while Google has more than 100 services that they provide inside the platform. And it just basically, it's a lot. Okay, if you are coming from a company or from a team that is working on a monolith, this is just not new vocabulary. This is just basically madness. Okay, it becomes a lot of things to keep in mind. Of course, you will say, oh, some of this stuff can be used in a monolith. Okay, I can use Kafka and offload the work like that. And you are like, yes, you can, but you don't have to. The difference is now with your distributed system, you basically have to use all these technologies. With the technologies, it came also new patterns and new ways of doing stuff. And I'm going to mention a couple of them today. One of them is basically eventual consistency. So what eventual consistency is very simple. Is that information will be consistent eventually. Okay? That sounds very simple, isn't it? So what does that mean? That means that when you have an order, okay, you make an order, and basically you have a projection, which is a copy of the inventory in your database. And you check that you have enough stock. So you say, okay, I have enough stock, I create the order created event, and that just gets consumed, gets processed, and you update, and then you update the projection again, and you have zero stock. Lovely, everything works. Now, the difference between when the consumer here on the inventory is updating this information and when the order consumer is updating the projection information, that is basically the eventual consistency. And normally, in normal circumstances, this is going to be milliseconds. But there is an application here, and there is an infrastructure thing here, which any of those can break. And that means that eventually may also mean never. So what happened, or just to put an example, what happened if two people just click at the same time or buy? So what is going to happen in a monolith, it will be, everything works on the transaction, the database normally on a monolith, and the second one just fails, and that's it. You go back to the front end, and everything fails. So what happened on a distributed system is that basically you go to the order API, both get through, you both will get, your order has been added to the system or whatever, and eventually the second one will fail. Basically, on the inventory consumer will fail, and I don't know, you receive a message later saying, okay, sorry, we oversold, and we cannot sell you this anymore because we are not restocking. Okay, something like that. And that's annoying. But there is another scenario where basically, what happens if it happens further down the line? So, or not even that. What happens if you have a stock and you have everything, but there is a problem? So for that, we have the saga patterns. Because, well, if we go again, basically, we buy the thing, we create the event, the inventory consumer removes the stock, you update the projection, and at the same time, after that, you go to the payment. You will say, oh, but the user puts that in the UI, blah, blah, blah. But if you think on Amazon, for example, you don't put the card there. You put it once, and then it just charges you whenever it charges you. And what happens if that payment fails? So if that payment fails, you basically have to undo everything that had happened until now. Because you don't have transactions, you have to do it manually. You are no longer writing logic that works, you are writing logic to handle the failure of business logic, which is absolutely crazy. In this case, you basically fail here and generate an event that is payment fail, and that event is being listened by the inventory consumer that will put the inventory back, and at the same time is being listened by the order consumer that will update the order information. And you will say that's it, but no, because the inventory back is stock added, and it will update also the projection. So this complexity is going to change the way you think about the problems and the way you basically have to deal with all this stuff. Of course, there is a human aspect on top of this. When you are working on a monolith, Normally, or in normal circumstances, based on my experience, mostly, you are working in horizontal teams. These horizontal teams are basically teams based on a skill. So you are a front-end developer, you work with the front-end developers. You are a back-end developer, you work with the back-end developers. You work in DBAs, you are only working on the DBA and systems, etc. All of this works like that. Now, when we are moving to distributed systems, this is not scalable. Okay? You cannot really do that. So what ends up happening is that teams become to be more of a vertical team based on domain. So in this case, you will have a team that is in charge, I don't know, of the order, and this team will be in charge of the UI, the team will be in charge of the backend, the infrastructure, the database, the monitor the deployment, monitor the logs, the incidents, absolutely everything. Okay? You build it, you run it, you own it. Somebody said it earlier, but that's exactly what happens. Okay? That's exactly how it works. And this adds a lot of overhead because teams are not going to be as big as they are here. So you are not going to have one person to do one of the tasks. You're going to basically have a team of 3 or 2 that just handles everything. And that's it. Okay? Like, that's it. There is no other way. So you have to learn Terraform or CloudFormation or Assembly or whatever it is. You have to learn your, I don't know, if the front end is Angular or React or JavaScript, it will be JavaScript for sure. So JavaScript, and then you have to learn the backend, and you have to learn how to do test and how to do all the stuff. And it takes a lot of time. It adds a cognitive load to everything, basically. And you know, you just basically need to know all the stack. And this can be a little bit of, I don't know how to say it in English, but basically it can lead you to burnout if you don't do it properly or you are just going crazy, moving everything to there. So you will be thinking that after me talking for about 20 minutes here, saying how bad the distributed systems are, why are we going to distributed systems, or why Netflix is in distributed system, or Uber, or whatever? Because there's basically one thing: is that the pain of the pain of the monolith is just greater than the pain of the distributed system, and we don't choose to move to distributed systems because we want to. We just choose to move to distributed systems because we have to. There is no other reason. Okay? We do this because you have to. So, but not everything is bad. Okay? When you are using distributed systems, not everything is bad. Earlier, when I was talking about the monolith, I was saying that code starts to talk to each other way too much, and things that shouldn't be calling each other are just basically happening. So that, it used to be, or it's supposed to be, a logical separation if you have a monolith, even if it doesn't happen. But when you have distributed systems, the thing is like that separation is just not logical. Okay? You cannot just call a different database. The system is not going to let you. So that separation, the clear separation of boundaries, is fully happening when you have distributed systems. And this means that you know what you own. Because one of the big problems of working on a large code base with another 200 engineers is that absolutely nobody knows what they own, and nobody wants to touch anything that they are sure or not sure they own, because they can break things that they don't want to break. And this doesn't happen here. So when you are in a distributed system, you will know what you own, and you also know what the systems you depend on are owned by. So you know which team owns basically not everything, but it's very kind of easy to identify all these things. On top of that, you could also make, this is the thing that is like, oh, one microservice is down and the entire application is still working. Yeah, this is possible. It's normally not like that. Okay? Normally it doesn't work like that, but this is possible. In fact, Netflix does it. But Netflix does it in a different way for a different reason, because they basically tune down features, so they put more generic ones whenever a new release is coming and is consuming basically everything. So, but anyways, if something is down, most of the application, everything that gets affected by it will be down as well. So it is just what it is. Of course, the other reason is scalability. Now, some of you may say, oh, but Shopify scales, and Shopify is a monolith. And that is true, okay? Shopify is amazing. Every year, they do this kind of thing that is like for the Black Friday, they put a thing online, and it's just a website that is amazing with all the stats and all of that. And they scale to the hundreds and hundreds of replicas of the monolith. The difference with Shopify and your company is that your company doesn't have the budget Shopify has for the Black Friday weekend. That's basically it. And when you scale, if you do, so you can scale a monolith, there is no problem. You just put a load balancer on top and 300 instances, and that's it. You know, your monolith scales. But this is extremely expensive. The good part of the microservices is that you scale exactly what you need to the level that you need at the moment that you need, and nothing more and nothing less. And that's it. That is very good for terms of the money. You know, you spend the exact money you have to spend to make your customers happy. And you have to put also like a ceiling, okay? On the scale on the top, just put a ceiling, because otherwise you will see, you know, every year we see all these people like, oh, I spend 90 grand on Vercel or whatever. And this is why, okay? Because they don't put a ceiling on top and it scale to the moon, and now we have a problem. So I want to mention here, because I don't have another slide for that, the fact to use the right tool for the right task. So this doesn't mean, that sentence doesn't mean that you have to rewrite one application that you have running there in Rust because it is 1% faster than in, I don't know, PHP. It just means that if you have a module or you have the idea of creating like a system, a big one about machine learning, and 90% of the internet works in Python, in machine learning, you may as well do that in Python in there. This doesn't mean that, you know, like you just want to do an API in, I don't know, OCaml, because it's full and it's online and it's trending. No, that, you know, the right tool for the right task doesn't mean that, just to keep that in mind. Here, for now, we've been talking about the two extremes, okay? We've been talking about distributed systems, and we've been talking about a monolith being an absolute mess. But of course, there is a step in between. So the step in between is basically what we call the modular monolith. A modular monolith is nothing else than a proper monolith or a monolith built properly. So from the beginning, when you started to create your monolith, you had clear boundaries on things that could happen and could not. And basically, to access from module 2 to module 4, you basically have to go to the public interface of module 4, otherwise you cannot do the call. This is very hard to achieve, but it's possible. And if you're thinking to move to microservices, it's also a good idea to basically refactor first the monolith or parts of it to be able to do it easily. Because once you have a monolith like that, properly structured, you don't need to move everything out. You can just move whatever it hurts. You know, you have here your little module, and you basically move that, and maybe you have another section when you have, I don't know, a PDF generator that is consuming most of the RAM, and you don't know why. There is a bug or something that nobody understands. Why it's consuming, you know, gigas of RAM every time you are doing a PDF? So you just move that out to a container and use that, okay? Move small and move what it hurts, and then you can decide to move everything else. Because, you know, everything's working. Like moving to microservices, it doesn't really provide any value more than, you know, if you need to scale or you need to do, you know, you need to move necessary stuff. Like if your PDF is collapsing the whole thing, you may as well move it because, you know, why to break it? So just to wrap up here, some people will ask, okay, so then what do I have? What do I have to do? You know, do I pick a monolith? Do I pick distributed systems? Well, it really depends. Well, in IT, everything depends, to be honest. Let's be honest on that. And it depends on what you want to achieve. So if you have like a small team or a small domain, or your priority number one is basically shipping features very, very fast, the best thing you can do is basically a monolith, keep working with the monolith until it's too big that you basically have to split it. And if you have the team expertise, because this is another thing on the distributed systems, not everybody is, or is aware, not aware, but not everybody has worked with them, so it's harder, let's call it like that, to move. If you have problems of teams blocking each other, you have scalability issues, and of course, if you have the maturity, budget, and I don't know, patience to move to the distributed systems, then you can move to the distributed systems. Moving to distributed systems or monolith is not a badge of honor, or it's not a badge to put in LinkedIn. It's just basically another tool to solve a problem, and that's it. Okay, so that was the talk. That was me. I hope you like it.